You guys have a handle on functions at this point. We've been talking about functions quite a bit. Remember, functions are relations where each input or x value has one unique output or y value. But today we're going to get specifically into something called a one-to-one function and inverse functions. So we're going to take functions and go a little more in depth with them today. And this is building you up to talk about exponential functions and logarithmic functions in the next couple of lessons. So some definitions. A function is one-to-one if every y value or output has a unique x value or input. So if it's a function, each x has a unique y, and if it's a one-to-one function, then each y has a unique x. If you have a and b from the domain of your function f, if a is not equal to b, that implies that f of a is not equal to f of b. So in other words, if you have two x values that aren't equal to each other, then the y values will not be equal to each other in a one-to-one function. If you look at the graph of a one-to-one function, the graph will pass something called the horizontal line test. Remember, to test to see if we had a function, we did the vertical line test, where you sweep a vertical line across the graph. And if a vertical line only touches at most one point at a time, then you pass the test for a function. If at any time a vertical line goes through more than one point, then the graph is not one of a function. Well, the horizontal line test is the same principle, except with a horizontal line. As you sweep a horizontal line over a graph from top to bottom or bottom to top, if it's a one-to-one function, then that horizontal line will never go through more than one point simultaneously. So you can go through 0 or 1 points, and that's it. If it goes through more, then your function is not one-to-one. All right, so let's look at an exercise or two where we decide if something's one-to-one. First function, we have f of x equals negative 5x plus 2. And we need to decide whether or not this function is one-to-one. It is a function. For each value you plug in for x, when you multiply by negative 5 and add 2, you'll get a unique value for y. You won't have two different x's that'll give you the same y. But is it for the function part, I mean, your x's won't repeat. You won't have same x giving you two y's. Sorry, I said that wrong. I was already jumping to the one-to-one part of it. Yeah, so it is a function. You put in an x, each x will only give you one y back out. So at no time will an x value give you two or more y's. So it's definitely a function. And then to decide if it's one-to-one or not, you have to figure out, will each y value match up with only one x value, or do your y's ever repeat? If your y's repeat, then it's not one-to-one. Well, the definition for a one-to-one function tells us that a not equal to b implies f of a not equal to f of b. So two different x's we should have two different y's. So we can take the contrapositive and say, well, f of a equals f of b implies a equals b. And we can use that contrapositive to help us to determine, if this is one-to-one or not. So f of a equals f of b. Start with that. You've got negative 5a plus 2 equals negative 5b plus 2. So you got negative 5a equals negative 5b, a equals b. So just start out assuming that your y's are equal, and then you plug in a and b, and as you go through, you find out that a and b are equal. So this, by definition, tells us that our function f of x is one-to-one. Okay, so that's one way to figure out whether it is one-to-one or not. Another example of a function that you want to decide, is it one-to-one or not? F of x equals absolute value of 2x plus 1. Okay, it is a function, and they tell us that, and if you go ahead and graph it, you'll see it passes the vertical line test. Or if you think about putting x values in, your x's will never repeat. Each x will only give you one y value back. But deciding if it's one-to-one or not, we have something interesting that happens. We have some x values that will show us that this is not one-to-one. This will not pass the horizontal line test. Okay, for example, let's say we put in, let's say we have x equals 3. So we have that. Well, f at 3 is the absolute value of 2 times 3 plus 1. So that's the absolute value of 6 plus 1. Absolute value of 7, which is 7. Okay, so the x value of 3 only gives us one y value back, so it is a function. But we have to ask ourselves, is there another x value that will give us the same y value? And if there is, then it's not one-to-one. So let me think for a second here. Is there something I can plug in that I would get 7 back? And indeed there is. Let's say I plug in -4. Absolute value of 2 times -4 plus 1 equals absolute value of -8 plus 1, which is the absolute value of -7, which is 7. Two different x values gave the same y value back. So this function is not one-to-one. Okay. And again, you can also look at the graph and decide if it passes the horizontal line test or not. All right, let me pull up my graphing calculator here. Let's put in f of x equals -5x plus 2 first. Let's hit graph. And there's the line. Slope's -5, y-intercept is at 2. Actually, let me go ahead and just do a standard window there so you can see the y-intercept at 2. This passes the vertical line test, passes the horizontal line test. So this is a function and it's one-to-one. Okay, now let me instead put in absolute value of 2x plus 1. Value 2x plus 1 and hit graph. It's a V shape. That's the classic absolute value shape. All right, vertical line test, sweep across, only crosses one point at a time, but horizontal line test gets failed because horizontal line test, as soon as you go past this little point right here at the V, horizontal line test up here is always touching 2 points at a time, horizontal line. So this is not one-to-one. So that's a way to determine. All right, so this one-to-one function, one-to-one, we can use our knowledge about that to help us now talk about inverse functions. Certain pairs of one-to-one functions undo each other, and these functions are called inverse functions. Okay, let's say you have a one-to-one function called f. And you have another function, g, that's also one-to-one. If you can do the composition of f of g and get x, and also do the composition of g of f and get x, then you know you have a pair of inverse functions. F is the inverse of g, g is the inverse of f. Okay, so let's look at an example where we have to show that two functions are inverses. Okay, we've got the function f of x equals 4x plus 3. Okay, this is a function, linear function, slope of 4, y-intercept of 3, passes the horizontal line test. This one is 1 to 1. Then we have the function g of x minus 3 over 4. Actually, another linear function, because you could also write this as 1/4 x minus 3/4. So if you want it in the slope-intercept form, you see the slope is 1/4, y-intercept's at negative 3/4. So it's another 1 to 1 function. So the question is, are they inverses? Okay, let's do the composition of functions. The domain and range for each of these is negative infinity to infinity, so I don't have to worry about any kind of restrictions on domain. Oops, sorry about that. Should I do an infinity symbol? Try that again. Okay, so for both of them, domain and range are negative infinity to infinity. So let's find the composition of the functions. Let's do f of g of x first. Remember, f of g of x, you're taking f of x, and in place of x, you're plugging in g of x. Let's see, 4 over 4 reduces, so you have x minus 3 plus 3, which equals x. So far that checks out. And then you want to do g of f of x. That's the one where you take g of x, and in place of x, put f of x. And that works out too. So yes, these one-to-one functions are inverses of each other. If you had done the composition and not gotten x, then you would know they're not inverses of each other. And that's how you can tell. Now let's say you have a function and you want to find its inverse. Take your function f of x, replace with y. Like, so you already know it's 1 to 1, so you want to find its inverse. You swap the x's and y's in the equation, solve for y, replace y with this notation. This notation, the f is the name of the function. This little negative 1 is not an exponent, rather it means inverse of x. Make sure domain and range are swapped too, and any restrictions on the domain of the inverse should be listed. Okay, for example, let's say you have y equals 4x minus 5. Okay, this is a function, and we know it's 1 to 1. It's the equation of a line. It's a function. It's not a horizontal line, so it is 1 to 1. If you graph it, it'll pass the horizontal line test. All right, so to find its inverse, go ahead and swap the x and y, because a function and its inverse essentially undo each other. So you swap the x and y, solve for y, and instead of y, you can write f, inverse of x. The domain and range of the original function was negative infinity to infinity. So we don't need to worry about specifying anything about domain or range down here with the inverse. When you swap the x and y here, what happens is the ordered pairs of your inverse are going to be the x's and y's swapped from the ordered pairs of your original function. And the domain and range are going to get swapped for the inverse. But if your domain and range are both negative infinity to infinity, then there's no sense in talking about swapping. Okay. So there you go. There's its inverse. Okay, and let's look at one where you have to do some restrictions. F of x equals square root of 6 plus x. And you're also told that x is greater than or equal to negative 6. So the domain is negative 6 to infinity. And if you look at the range, you plug in negative 6, you're going to get 0. Plug in bigger numbers, you're going to get bigger and bigger values. So the range is 0 to infinity. Okay, this is a function. And it is 1 to 1. It would pass the horizontal line test. It passes both the vertical line test and the horizontal line test. So we want to find the inverse. So we'll write it as y equals square root of 6 plus x. And then we'll swap the x and y. Let's see, solve for y. So we need to square both sides. Subtract 6 from both sides. And then use the function notation, inverse function notation, instead of y. But we can't stop there. Since the domain was restricted from negative 6 to infinity, and since the range went from 0 to infinity, the domain of our inverse is 0 to infinity. So we have to state right here that x is greater than or equal to 0. If we don't state that, then we don't even have a one-to-one function right here. Because without stating x greater than or equal to 0, x squared minus 6 is a parabola cupped up, shifted 6 units down, which is a function, but not one-to-one. But if you limit your domain to be 0 to infinity, it's only going to be half of a parabola, and that particular function is 1-to-1. So that's very important here, that you have to state that x is greater than or equal to 0. Otherwise, you're not correct. So just to let you know. So be careful with that. Watch out for your domain and range. And a little bit about the graphs. The graph of a function's inverse can be obtained by reflecting the function's graph across the line y equals x. The ordered pairs of a function's inverse will be the ordered pairs of the function with the x and y values swapped. Okay, so I think we can use our calculator for this. I'm going to go back to the two functions we just worked with. I'm going to pull the calculator up. Okay, earlier we did y equals 4x minus 5. Oh, something with my mouse lately, it like randomly double clicks stuff when I haven't double clicked. Don't know why it does that. All right, and then the other one was x plus 5 over 4. And I'm going to go ahead and make that, see what I mean? It keeps doing that, it's driving me crazy. All right, I'm going to go ahead and make this one thicker so you can tell them apart. I'm also going to do a y equals y sub 3, and it's just y equals x. I'm going to graph all three. Your y sub 1 is this thin line right here. That was the y equals 4x minus 5. Your y sub 2 is this thicker line here, x plus 5 over 4, y equals x plus 5 over 4, and then y equals x is this line here. The function and its inverse are reflections of each other across the line y equals x. You take this thin line, as soon as you reflect it across this y equals x, it matches up perfectly with this thick line. Or vice versa, thick line reflected across y equals x matches up perfectly with this thin line. So the graphs of a function and its inverse will be perfect reflections across y equals x. Also, the ordered pairs will be their x's and y's swapped. So like you look at the table, you've got, for the first function, you got x is 0, y is negative 5. And then as soon as you go to x is negative 5, the second function y is 0. So notice the x's and y's are swapped. Here you got 0, negative 5. Here you got negative 5, comma 0. And that's going to be true for every ordered pair. Every ordered pair of y1, you can swap the x and y and get every ordered pair from y2. Oops, sorry about that. Pulling up the slides again. We did this one. Let's go ahead and punch that in the calculator as well. Okay. I'm going to leave y equals x as number 3. We had square root of 6 plus x. We also have x squared minus 6. Go ahead and make that one thicker. And hit graph. And then now you'll see why we have to do the restrictions. The thin one is the first y1, that's square root of 6 plus x. Notice x is greater than or equal to negative 6. It starts at negative 6 here, goes off to the right forever. The y starts at 0, keeps going right and up. Then the inverse is the thick one. The calculator did not limit the domain, so you're going to need to be aware that the domain is limited from 0 to infinity. So it's just this half of the parabola that we're considering. So ignore this piece. Don't pretend that's not there. So this half of the parabola, if you reflect it across the line y equals x, it matches up with this thin parabola that's half parabola that's facing to the right. Or vice versa. This thin half parabola that's facing to the right, if you reflect it across y equals x, it would match up with this right half of this thick parabola. So you have to pretend this part's not here right now. And again, if you go to your table, x's and y's are swapped. Like if x is negative 5 and y is 1 here, then down here x is 1, y is negative 5. So every ordered pair that's in the domain of each can be swapped and get ordered pairs for the other. All right. Well, that covers inverse functions. Make sure you practice this enough and have it down, because when we talk about exponential functions and logarithmic functions, we are going to be hitting inverses pretty heavily, one-to-one and inverses. So this is a glimpse of things to come. Well, thank you for joining me, and I hope to see you again very soon.